While you were pouring your morning coffee on October 21st, 2025, something happened that you didn't hear about on the news. NASA, in coordination with an international network of observatories, quietly activated a planetary defense protocol. No press conference. No headlines scrolling across CNN. Just a single technical bulletin buried in astronomical databases where only professionals would think to look. The target? An interstellar visitor currently hiding behind the sun, invisible to ground-based telescopes, racing toward its closest approach to Earth. They're calling it routine astrometry. They're saying it's standard procedure. But when you look at the timing, the language, the coordinated silence across multiple agencies, you start to realize that what they're not saying might be far more important than what they are. And if you've lived long enough to remember when governments told us Agent Orange was safe, when tobacco companies swore cigarettes didn't cause cancer, when officials assured us there were weapons of mass destruction in Iraq, then you know that silence from authorities often speaks louder than their official statements. So today I'm going to show you exactly what that bulletin says, what it means, and why the world's most powerful space agencies are watching this object with an intensity they're trying very hard to downplay. Let me take you back to October 21st, 2025. For most people, it was just another Monday. The news was filled with the usual stories, political theatre, celebrity gossip, weather patterns shifting into autumn. But in the world of planetary defense, something extraordinary was unfolding, and it happened so quietly that even dedicated space enthusiasts almost missed it. At approximately 1437 UTC, the Minor Planet Center, the official repository for astronomical observations coordinated by the International Astronomical Union, published a notice that would have seemed mundane to casual observers, but sent ripples through the astronomical community. It announced the activation of an International Asteroid Warning Network campaign, something that happens only when an object warrants coordinated, intensive monitoring by observatories worldwide. The object in question? Comet 3 I Atlas, the third known interstellar visitor to our solar system, currently positioned almost directly behind the Sun from Earth's perspective, invisible to our most powerful ground-based telescopes. Now let me be clear about what the International Asteroid Warning Network actually is, because understanding this organization is crucial to grasping why this activation matters. The IAN was established in 2014, born from the realization that humanity needed a coordinated early warning system for objects that could potentially threaten Earth. It's not some fringe group of conspiracy theorists or amateur skywatchers. This is the real deal, a network that includes NASA, the European Space Agency, the space agencies of Russia, Japan, China, and dozens of professional observatories across every continent. When IAWN activates a campaign, they're essentially saying that an object requires the focused attention of humanity's best astronomical resources. The bulletin specified that the campaign would focus on intensive astrometry, the precise measurement of the object's position and trajectory. The observation window? November the 27th, 2025, through January 27th, 2026. 2 full months of coordinated tracking with participating observatories required to submit their credentials and observation plans for vetting before being approved to contribute data. Let that detail sink in for a moment. They're not just asking for observations, they're screening who gets to participate, ensuring that only verified professional-grade data enters the official record. Does that sound like routine monitoring to you? When was the last time you heard of NASA vetting amateur astronomers for a standard comet observation campaign? The timing of this activation tells its own story. October 21st wasn't chosen randomly. That was the precise date when 3I Atlas reached solar conjunction, the astronomical term for when an object passes directly behind the Sun from Earth's perspective. At that moment, the comet was approximately 0.2 astronomical units from the Sun, less than a fifth of the distance between Earth and our star, subjected to temperatures and radiation that would vaporize most known materials. And here's what makes this timing so deliberate. Perihelion, the point of closest approach to the Sun, was scheduled for October 29th, just 8 days later. NASA activated this campaign exactly when the comet entered the most intense phase of its solar encounter, the period when solar heating would trigger any reactions, any changes in its structure, any behaviors that would reveal what this object truly is. But they activated it when none of us could see what was happening. That's the part that should make you pause and think. The comet is currently positioned in the constellation Virgo, sharing the same patch of sky as our Sun, which means attempting to observe it now would be like trying to see a candle flame at noon while staring directly at a stadium floodlight. Professional observatories have protocols against pointing their instruments that close to the sun, because the light would not only wash out any possible observation, but could damage sensitive equipment worth millions of dollars. So when the bulletin was published on October 21st, the astronomical community received their marching orders to prepare for observations that wouldn't actually begin until mid-November, when the comet would finally emerge from behind the solar glare into the pre-dawn sky. What happened during those hidden days? That's the question that keeps circulating through astronomical forums. That's the whisper you hear when professionals think the public isn't listening. From October 21st through early November, 3i Atlas was invisible to ground-based observation, subjected to the most intense solar radiation and gravitational forces of its entire journey through our solar system, and nobody on Earth could watch what was happening in real time. The only assets that potentially could observe during this window were space-based telescopes and probes, instruments like the Solar and Heliospheric Observatory that continuously monitors the Sun's corona, or the European Space Agency's JUICE probe, which, as it happens, was scheduled to make observations of 3i Atlas on November 4th, 2025. But here's where it gets interesting. Those JUICE observations, captured by instruments specifically designed to study icy bodies in the outer solar system, won't be made public until February 2026, a full 3 months after they're taken. Why the delay? Official explanation: data processing, analysis, peer review. But you've lived through enough government operations to know that when data is delayed, it's often because someone wants time to control the narrative before the public sees the raw information. The activation bulletin included another detail that might seem technical, but carries profound implications. It specified that the campaign's primary focus would be astrometry rather than spectroscopy or photometry. For those unfamiliar with astronomical terminology, that means they're prioritizing the tracking of the object's exact position and trajectory over analyzing its composition or brightness. Why would that be the priority? Astrometry is what you do when you need to predict where an object will go, when you need to calculate whether its path might change, when you're concerned that its orbit might not match theoretical predictions. It's the foundation of planetary defense, the first step in determining whether something poses a collision risk. They're not primarily asking observatories to study what this object is made of. They're asking them to watch where it's going and whether it's going exactly where mathematical models say it should go. And there's one more layer to this that anyone who remembers the Cold War will recognize immediately. The bulletin was published without fanfare, without press releases, without the usual NASA public outreach that accompanies space discoveries. It appeared in technical databases frequented by professionals, the kind of places where information is shared between experts but rarely trickles down to public awareness. This is how governments communicate when they want to prepare the people who need to know, while keeping the general public unaware, until there's a clearer picture of the situation. It's the astronomical equivalent of DEFCON levels changing without public announcement, of military readiness increasing while the news talks about everything except the reason why. Dr. Avi Loeb, the Harvard astronomer who chairs the Galileo project and has spent years advocating for serious scientific investigation of interstellar objects, published an article on October 22nd, one day after the EAWN activation. In that piece, which you can find on his Medium page if you want to verify this yourself, Loeb noted that 3i Atlas presents multiple anomalies that warrant intense scrutiny during its perihelion passage and emergence from solar conjunction. He didn't use alarmist language, he didn't claim it was alien technology, but he did make clear that this object doesn't behave like typical comets, that its characteristics raise questions current models struggle to answer, and that the observation window opening in late November represents perhaps our only chance to gather definitive data before it races back out into interstellar space, beyond the reach of our instruments forever. So here we are, with the Planetary Defense Network quietly activated, observation protocols established, and a 2-month countdown beginning on November 27th for the most intensive study of an interstellar object ever attempted by humanity. They're preparing for something. They're coordinating resources across international boundaries in ways that only happen when the situation demands it. And they're doing it all while the object remains hidden behind the sun, during the exact period when solar forces could trigger changes that would reveal its true nature. The question isn't whether they're watching. The question is what they expect to see when that comet finally emerges into view. What happens during perihelion when temperatures soar and radiation peaks? What changes might occur to an object of uncertain composition, subjected to forces it may never have experienced before? And why does NASA want hundreds of telescopes ready to observe the moment it becomes visible again? The countdown has started, the protocols are in place, and in about 5 weeks from now, when 3i Atlas emerges from behind the Sun, we're going to find out whether this quiet activation was routine caution or preparation for something no press release could adequately explain without causing the exact kind of public reaction that governments spend enormous resources trying to avoid. But before we can understand what they're preparing for, we need to decode exactly what that bulletin says, and more importantly, what it deliberately doesn't say. When you read an official document from NASA or the International Astronomical Union, you're not just reading information, you're reading carefully calibrated language, words chosen by committees, phrasing that has passed through legal review and public relations departments, sentences constructed to inform professionals while keeping the general public calm and unalarmed. Learning to read between those lines is something you develop over decades of watching how organizations communicate during situations they don't want to fully explain. And the ION Bulletin published on October 21st, 2025 is a masterclass in saying everything and nothing simultaneously. Let me walk you through the document section by section, and I'll show you where the carefully neutral language starts to crack and reveal the concerns underneath. The bulletin opens with standard astronomical nomenclature: designation of the object, orbital parameters, current position, predicted trajectory. This is boilerplate, the kind of information that appears in every astronomical circular published by the Minor Planet Center. But then comes the key phrase, the sentence that transforms this from routine documentation into something far more significant. Due to orbital uncertainties and photometric anomalies observed during pre-conjunction phase, IAWN is activating coordinated astrometric campaign to refine trajectory predictions and monitor for non-gravitational perturbations, orbital uncertainties. Let's pause there. When astronomers say an object has orbital uncertainties, they mean its actual position doesn't quite match where mathematical models predict it should be. For most objects in our solar system, this uncertainty can be reduced to negligible levels after just a few nights of observation, because these objects follow predictable paths governed purely by gravitational forces from the Sun and planets. But 3i Atlas has been observed extensively since its discovery. Professional observatories have been tracking it for months. Yet here we are, days before perihelion, and they're still talking about orbital uncertainties significant enough to warrant an international observation campaign. What does that tell you? It tells you the comet isn't going exactly where pure gravity says it should go. Now, to be fair, comets often display what astronomers call non-gravitational forces. When sunlight heats a comet's icy surface, material vaporizes and jets away, creating tiny rocket-like thrust that can slightly alter the trajectory. This is normal, well-documented, completely expected for comets. But here's what's not normal: the magnitude of the deviation. According to preliminary data discussed in astronomical forums by professionals analyzing the pre-conjunction observations, 3i Atlas showed a brightness offset, a term that means its actual brightness and the position of its brightest point didn't align with standard comet models. In practical terms, the nucleus, the solid body at the heart of the comet, appeared to be displaced from the center of the surrounding coma, the cloud of gas and dust that envelops active comets. That displacement suggests asymmetric outgassing, material venting from one side more than the other, which would create uneven thrust affecting its trajectory in ways that pure gravitational calculations wouldn't predict. The bulletin specifies that the observation campaign will focus particularly on astrometry, from November the 27th through January 27th. Why that specific window? November 27th is when 3i Atlas will finally be far enough from the Sun in our sky to be observable by ground-based telescopes in the pre-dawn hours. By that date, it will have survived perihelion, endured maximum solar heating, and whatever changes that extreme environment triggered will be evident in its behavior. January 27th, the end date, is significant because by then the comet will be moving rapidly away from the inner solar system, its brightness fading as it retreats toward the outer planets and eventually back into interstellar space. That 2-month window represents the entire period during which professional-grade observations will be possible. Before November 27th, it's too close to the Sun. After January 27th, it will be too faint and too far for detailed tracking. This is humanity's only chance to gather definitive trajectory data. But there's another layer buried in that timeline. December 19th, 2025 sits right in the middle of that observation window. That date marks 3I Atlas reaching its closest approach to Earth, approximately 0.6 astronomical units away, roughly 56 million miles. In cosmic terms, that's remarkably close for an interstellar object, close enough for amateur astronomers with decent equipment to potentially spot it, close enough for professional observatories to gather spectroscopic data revealing its chemical composition in unprecedented detail. The bulletin doesn't explicitly highlight December 19th, but every astronomer reading it knows that date will be the peak of observation activity, the moment when humanity gets its clearest look at this visitor before it races away forever. Now let's address the phrase, photometric anomalies observed during preconjunction phase. Photometry is the measurement of an object's brightness over time. For comets, brightness typically follows predictable patterns based on distance from the Sun, a relationship described by something called the Hale-Bopp formula that has worked reliably for decades. As a comet approaches the Sun, it brightens in a smooth curve. As it recedes, it dims along that same curve. Simple physics. But 3I Atlas apparently didn't follow that curve as precisely as expected during its approach to solar conjunction. The term anomalies is deliberately vague, chosen specifically because it acknowledges something unusual, without quantifying how unusual or speculating about causes. But astronomers discussing these observations in professional forums have noted that the comet's brightness varied in ways that suggest either complex, rapidly changing outgassing patterns or, more intriguingly, that its reflective properties don't match typical cometary material. The bulletin also specifies that participating observatories must be vetted, required to submit their observation plans and equipment specifications for approval before their data will be incorporated into the official IAWN database. On the surface, this seems reasonable. You want quality control. You want to ensure that amateur astronomers using backyard telescopes aren't submitting poor data that contaminates professional analysis. But there's another interpretation, one that becomes more plausible when you consider how governments handle sensitive information. By requiring vetting, they create a filter. They establish control over what data becomes part of the official record and what doesn't. If an amateur observatory happens to observe something unusual, something that doesn't fit the preferred narrative, that data can be quietly excluded from the official database on technical grounds, equipment not meeting specifications, observation methodology not following protocols, data quality insufficient for inclusion. I'm not saying that's what's happening. I'm saying that's what the structure allows to happen if authorities decided certain observations shouldn't enter the public record. Dr. Avi Loeb addressed this campaign directly in his October 22nd article. He noted, and I'm paraphrasing here, but you can verify the original text, that the intensive astrometry focus suggests particular interest in whether 3I Atlas will exhibit trajectory changes that can't be explained by natural outgassing alone. Loeb has been vocal about the need to seriously consider the possibility that some interstellar objects might be probes or debris from extraterrestrial technology. He's not claiming 3I Atlas is artificial. He's arguing that we should look at the evidence without preconceptions and be willing to follow the data wherever it leads, even if that destination makes us uncomfortable. The fact that IAWN is prioritizing precise trajectory tracking aligns with exactly the kind of observation you'd want if you suspected, even as a remote possibility, that an object might demonstrate propulsion or navigation capabilities beyond what natural processes produce. Here's what all of this means in practical terms. From November 27th through January 27th, hundreds of professional telescopes across 6 continents will be tracking 3I Atlas, with intensity usually reserved for potentially hazardous asteroids, objects whose orbits might intersect Earth. They'll be measuring its position down to fractions of an arcsecond, calculating its velocity to meters per second, watching for any deviation from purely ballistic motion. And they'll be doing this under a coordinated protocol that controls what observations get officially recorded and what gets filtered out. The data will be there, the analysis will happen. But the public narrative will be carefully managed, released through official channels only after experts have had time to interpret, contextualize, and frame the findings in ways that don't trigger panic or uncontrolled speculation. You've lived through enough decades to remember when governments insisted information needed to be classified for national security, when we were told that the public couldn't handle certain truths, that revealing raw data would cause more harm than good. Sometimes they were right. Sometimes that caution prevented unnecessary panic. But sometimes, and history shows us this repeatedly, that control over information was about protecting institutional credibility, avoiding difficult questions, buying time to develop responses to situations that had no good answers. Which category does this IAWN campaign fall into? Is it genuinely routine monitoring of an unusual but ultimately natural object? Or is it preparation for observations that might reveal something no press release could adequately explain? Mark your calendar for November 27th, 2025. That's when the official observation window opens. That's when ground-based telescopes will finally get their first clear look at 3i Atlas, after it emerges from behind the Sun, after it has survived perihelion, after whatever changes that extreme solar environment might have triggered. And that's when we'll start seeing whether this quiet activation was caution or prophecy. But there's another layer to this story, one that emerged on the exact same day as the IAWN bulletin, and this one didn't come through official channels at all. October 21st, 2025 wasn't just the day NASA published its technical bulletin. It was also the day when someone, claiming to be a data analyst working with the European Space Agency's gamma-ray observation program, posted a message on an aerospace forum that sent conspiracy communities into overdrive and left serious researchers scrambling to verify information that, if true, would fundamentally change how we understand 3i Atlas. Now, before I go further, I need to be absolutely clear about something. What I'm about to tell you has not been verified by official sources. The ESA has not confirmed any of these claims. No peer-reviewed paper has been published presenting this data. What we have is a social media post, anonymous, impossible to fully authenticate, that could be genuine whistleblowing or could be sophisticated disinformation. But given the timing, given the details, and given how quickly the post was removed from multiple platforms, this deserves to be examined with the same skeptical rigor you'd apply to any information that powerful institutions might not want widely discussed. The post appeared on October 21st, within hours of the IAWN bulletin going public. The account identified itself as someone with access to data from the Fermi Gamma Ray Space Telescope, a NASA space observatory launched in 2008 that continuously scans the sky for high-energy radiation, the kind emitted by exotic cosmic phenomena like pulsars, black holes, and gamma-ray bursts. According to the post, beginning in mid-September 2025, Fermi detected what the analyst described as a stable, repeating gamma-ray signature coming from the direction of 3i Atlas. Not a natural burst, not the random flaring typical of active galactic nuclei or other known sources, but a pattern. The analyst claimed that the signal exhibited periodicity, repeating on a cycle that didn't match any known natural mechanism, and that this signature persisted through multiple observation windows spanning several weeks. Let me break down why this claim, if true, would be so significant. Gamma rays are the highest energy form of electromagnetic radiation, more energetic than X-rays, more energetic than ultraviolet light, produced only by extreme physical processes. In nature, you get gamma rays from things like supernova, matter falling into black holes, or highly radioactive decay. Comets don't produce gamma rays. They're cold chunks of ice and rock that, when heated by the sun, release gas and dust, but nothing remotely approaching the energies required to generate gamma-ray emission. If 3i Atlas were genuinely producing a detectable gamma-ray signature, it would mean something about its composition or behavior fundamentally contradicts our understanding of what comets are and how they work. The post specified that the signature began appearing in Fermi data around September 15th, 2025, when 3i Atlas was still roughly 0.8 astronomical units from the Sun, well before perihelion, but within the range where solar heating would begin triggering outgassing in a typical comet. The claimed periodicity was described as approximately 7 hours, which intriguingly is close to the rotational period that some astronomers have speculated for 3i Atlas, based on its light curve variations, the way its brightness fluctuates over time. If an object were rotating and emitting directional radiation from a specific feature on its surface, you'd expect to see that signature appear and disappear as the object spins, creating a periodic pattern matching the rotation rate. That detail, that 6.7-hour cycle, is either a remarkable coincidence or suggests that whoever wrote this post had access to actual scientific data that included preliminary rotation estimates. The analyst claimed that the signal was initially dismissed as instrument noise or contamination from a background source, but as it persisted through multiple observation periods, it was flagged for review by senior mission scientists. According to the post, by early October, internal discussions were underway about whether to issue a formal observation alert to the astronomical community, but those discussions were allegedly shut down by higher-level administrators who determined that insufficient data existed to justify causing what they termed unproductive public speculation. The post claimed that the decision was made to continue monitoring quietly, using resources like the JUICE probe observation scheduled for November 4th, and to wait until post-perihelion analysis could either confirm or rule out the signature's connection to 3I Atlas. Within 36 hours of appearing, the post was removed from the original forum. The account that posted it was suspended. Copies that appeared on Reddit and other platforms were similarly deleted, though not before being screenshotted and archived by users who recognized that rapid deletion often suggests uncomfortable truths rather than baseless fiction. Now, does deletion prove authenticity? Absolutely not. Forums remove unverified claims all the time, especially when those claims involve government agencies and could constitute defamation or misinformation. But the speed and thoroughness of the removal, spanning multiple platforms that don't typically coordinate content moderation, raises questions about whether someone with reach wanted this particular story contained before it gained traction. For context, real whistleblowers, people who have revealed genuine government secrets throughout history, often face exactly this kind of rapid suppression. Think about Edward Snowden's NSA revelations, initially dismissed as implausible before evidence made denial impossible. Think about Daniel Ellsberg and the Pentagon Papers, information that officials insisted couldn't be true even as journalists verified every detail. Think about whistleblowers in corporate fraud cases, scientists raising alarms about tobacco or asbestos or pharmaceutical dangers, initially painted as alarmists or conspiracy theorists, until the evidence became undeniable. If you're old enough to remember these patterns, you recognize that institutional denial doesn't necessarily mean something is false. Sometimes it means it's true and inconvenient. Now, let's balance this with what we can actually verify. First, Fermi Gamma Ray Space Telescope data is publicly accessible through NASA archives, but with significant delays for processing and calibration. The raw data from September and October 2025 won't be publicly available until months after it was collected, which means independent researchers can't immediately check whether gamma ray signatures from 3I Atlas's direction actually exist in the record. Second, even if such signatures exist, attributing them to the comet rather than background sources would require careful analysis to rule out coincidental alignment with distant galaxies or other high-energy objects that happen to lie along the same line of sight. Gamma-ray astronomy is complicated precisely because sources can be difficult to pinpoint with precision. But here's what's interesting. There are verified spectroscopic anomalies in 3I Atlas that do suggest unusual composition. Observations from the Keck Observatory and the Very Large Telescope in Chile, taken between August and October 2025, detected strong nickel emission lines in the comet's spectrum. Nickel isn't rare in comets, but the ratio of nickel to iron observed in 3I Atlas doesn't match typical solar system ratios. Dr. Loeb has discussed this publicly, noting that the nickel signature, combined with the absence of corresponding iron lines you'd expect from natural mineral grains, raises questions about whether some of the observed emission could come from nickel tetracarbonyl, a compound that in terrestrial settings is associated with industrial processes. I'm not saying it's proof of anything artificial. I'm saying it's genuinely odd, genuinely unexplained by current models, and documented in peer-reviewed observations that anyone can verify. So we're left with this: an unverified claim of gamma-ray detection that can't be confirmed or debunked with publicly available data, posted anonymously on the exact day that planetary defense protocols were activated, quickly suppressed across multiple platforms, but containing details about rotation periods and timing that align with real observational data. You can dismiss it as creative fiction, someone with enough astronomical knowledge to make their story sound plausible, or you can file it away as one more data point in a growing collection of anomalies surrounding this object. What you can't do is prove definitively right now whether it's true or false, and that uncertainty That gap between what officials say and what leaked claims suggest is precisely where public doubt takes root and grows. The observation window opens on November 27th. If that gamma-ray signature is real, if it continues after perihelion, if JUICE data scheduled for release in February 2026 shows anything consistent with these claims, then we'll know. Until then, we're watching a story where the main character is hidden behind the sun, and the only information we have comes from carefully worded official statements and rapidly deleted posts that someone desperately doesn't want us discussing. But there's something else happening behind that sun, something predicted months in advance, and it's about to reach 3i Atlas in a collision of forces that could change everything we think we know about this object. Let me introduce you to someone you've probably never heard of unless you follow the most technical corners of space weather forecasting. Stephen Burns is an independent researcher who has spent years developing mathematical models of how the sun's magnetic field interacts with objects passing through the inner solar system, particularly comets whose icy composition can respond dramatically to electromagnetic forces that most people don't even know exist. Burns isn't affiliated with NASA or ESA or any major institution. He publishes his work on social media, posts detailed predictions on platforms like X, formerly Twitter, and has built a small but dedicated following among people who recognize that some of the most innovative thinking happens outside institutional walls, where careers and reputations aren't at stake if unconventional theories turn out to be wrong. On October 21st, 2025, the same day the IAWN bulletin went public, and the same day that unverified whistleblower post appeared, Stephen Burns posted a thread that sent a different kind of alarm through space weather communities. According to Burns, a coronal mass ejection, CME, had erupted from the sun's far side the previous day, October 20th, aimed directly at the location where 3i Atlas would be positioned on October 25th or 26th. And here's the stunning part. Burns had predicted this interaction months earlier, posting in July and August 2025 that as the comet approached perihelion, it would encounter specific electromagnetic conditions created by the sun's rotating magnetic field structure, and that those conditions would likely trigger not just natural solar activity, but potentially reveal whether the comet responded to electromagnetic forces in ways that purely icy bodies shouldn't. Let me explain what a coronal mass ejection actually is, because this is crucial to understanding why this collision matters. The sun isn't a static ball of fire. It's a seething mass of plasma, superheated gas so hot that electrons are stripped from atoms, creating an electrically charged fluid that generates powerful magnetic fields. Sometimes those magnetic fields become twisted and unstable, suddenly releasing enormous amounts of energy and hurling billions of tons of plasma into space at speeds approaching 2 million miles per hour. These eruptions are called coronal mass ejections, and they're one of the sun's most dramatic phenomena. When a CME hits Earth, and we've experienced several in recent years, it compresses our planet's magnetic field, triggers auroras visible at unusually low latitudes, and can disrupt satellites, power grids, and communication systems. They're beautiful, powerful, and capable of affecting technology across entire continents. Now imagine what happens when a CME doesn't hit a planet protected by a magnetic field, but instead slams directly into a comet with no such protection. The plasma, travelling at millions of miles per hour, carries embedded magnetic fields that interact with any conductive material they encounter. For a typical comet, which is mostly water ice and rock, the interaction produces spectacular visual effects, dramatic brightening, extended tails, but nothing fundamentally mysterious. The solar wind, which is essentially a continuous low-level stream of particles from the sun, already shapes comet tails and drives outgassing. A CME is just an intensified version of that process, a sudden surge rather than a steady flow. But Stephen Burns' models suggest something more complex for 3i Atlas. Based on months of detailed calculations posted publicly for anyone to verify, Burns argued that the comet's trajectory through the sun's magnetic field structure would subject it to forces that could reveal whether its composition includes significant amounts of conductive materials, metals or other substances that respond to electromagnetic forces more strongly than water ice does. He predicted specific dates when these interactions would peak, and October 25th to 26th was highlighted as a critical moment when a CME impact, combined with the comet's proximity to perihelion just 3 days later, would create maximum electromagnetic stress on whatever this object actually is. When that October 20th CME erupted from the sun's far side, space weather monitoring networks tracked it using instruments like Stereo A, a spacecraft positioned to observe the sun from an angle that Earth-based satellites can't see. The CME's trajectory was calculated based on its initial velocity and direction, standard procedure for space weather forecasting. And according to those calculations, confirmed by multiple monitoring facilities, the CME was indeed aimed at roughly the same solar longitude where 3I Atlas would be positioned on October 25th. Coincidence? Burns had predicted CME activity in that timeframe based on solar rotation cycles and historical patterns. Whether his prediction was scientific forecasting or lucky guessing depends on your assessment of his methodology, but the fact remains, he said it would happen, and something matching his description did happen. Here's where it gets fascinating from a physics perspective. If 3I Atlas is primarily composed of normal cometary material, water ice, dust, organic compounds, then a CME impact would produce specific observable effects. You'd expect dramatic brightening as the increased energy triggers explosive outgassing. You'd expect the tail to expand and potentially fragment as material is violently stripped away. You'd expect the light curve, the graph of its brightness over time, to show a sharp spike followed by gradual decline as the comet settles back to its baseline state. These effects are well documented. Comet Encke, one of the most studied comets in history, has been observed multiple times being hit by CMEs, and each time it responded exactly as theory predicts for icy bodies. But if 3I Atlas contains significant amounts of conductive materials, if its composition includes metals or other substances that can carry electric currents, then the CME impact would produce different effects. Conductive materials in a rapidly changing magnetic field experience what's called electromagnetic induction, the same principle that makes generators and electric motors work. The changing magnetic field induces electric currents in the conductor, and those currents generate heat, create forces, and can cause structural stresses that non-conductive materials wouldn't experience. In extreme cases, if an object has enough conductive material and the magnetic field change is violent enough, you could see effects that look less like natural outgassing and more like electrical discharge phenomena, the kind of thing you'd associate with lightning strikes or plasma interactions rather than simple ice melting. Stephen Burns predicted that if the comet responded to the CME in ways that suggested significant conductivity, we'd see specific signatures, unusual brightness patterns, not following the smooth curves of natural outgassing, rapid changes in the coma structure, the cloud of gas around the nucleus, potentially showing asymmetries or focused jets that don't align with simple solar heating, possible fragmentation, not from structural weakness but from electromagnetic forces creating internal stresses, and critically, trajectory perturbations, tiny changes in the comet's path that result from electromagnetic forces rather than gravitational influences, the exact kind of non-gravitational effects that the IABUN bulletin mentioned as the focus of their astrometric campaign. The CME was calculated to impact on October 25th or 26th, placing the event in the final days before perihelion on October 29th, and right in the middle of the period when 3I Atlas is hidden behind the sun from Earth's view. We can't observe it directly. Ground-based telescopes can't point that close to the sun. The only instruments that might capture this interaction are space-based solar observatories like SOHO, which monitors the sun's immediate environment, and potentially JUICE, if its November 4th observation window was designed to look for after-effects of this collision. But those observations, if they show anything unusual, won't become public knowledge for months, filtered through the same institutional review processes that control what data reaches public awareness, and what stays buried in technical archives until enough time has passed that its impact is reduced. Think about the timing here. October 20th CME eruption. October 21st, EAWN activates Planetary Defense Campaign. Unverified whistleblower post appears. Stephen Burns announces the predicted collision is incoming. October 25th to 26th, CME impact. October 29th, perihelion, maximum solar heating. November 4th, JUICE observations. November 27th, the object emerges from solar conjunction visible to ground telescopes for the first time since entering this extreme environment. It's a sequence, a carefully orchestrated timeline where every element builds on the previous one, and we're only seeing the setup, the payoff. The reveal of what actually happened during those hidden weeks won't come until the comet emerges and observers can see whether it's still behaving like a normal comet or whether something fundamental has changed. Burns has been documenting this prediction sequence for months, creating a public record that can't be retroactively altered, posting detailed calculations and reasoning that either will be vindicated by observations or proven wrong when the data comes in. That's the mark of genuine science, making testable predictions that can be falsified by evidence. If 3i Atlas emerges in late November looking exactly as standard comet models predict, with brightness and behaviour consistent with ice and dust, then Burns's electromagnetic interaction hypothesis goes into the failed theory pile. But if the comet shows any of those predicted anomalies, trajectory changes, unusual brightness patterns, structural modifications that suggest something beyond simple solar heating, then a fringe theory becomes something that demands serious institutional attention. You've lived long enough to remember when continental drift was considered fringe geology, when the idea that continents moved was mocked by establishment scientists who couldn't imagine a mechanism that would allow it, until evidence accumulated, until the mechanism was discovered, until the theory became so well supported that denying it became untenable. That's how scientific revolutions happen, not through institutional pronouncements, but through observations that force paradigm shifts whether authorities are comfortable with them or not. Maybe Stephen Burns is this generation's Alfred Wegener, proposing continental drift for comets, electromagnetic forces that establishment science hasn't adequately considered. Or maybe he's just wrong, and the comet will politely follow all the rules we expect. We're about to find out. The CME hit. The collision happened, or is happening right now as this video goes live behind the sun where we can't see, at temperatures and radiation levels that would vaporize most known substances, in an electromagnetic environment that could reveal truths no press release is prepared to explain. And all of this is occurring during what might be the most convenient cover story in astronomical history. A perfect alignment that renders the object invisible during the exact period when everything interesting might be happening. There's a term in astronomy for what's happening right now with 3i Atlas, solar conjunction. It means the object is positioned almost directly behind the sun from Earth's perspective, sharing the same patch of sky, making observation impossible because any attempt to point a telescope that close to the sun would flood the instrument with light millions of times brighter than the target. Solar conjunction happens to planets regularly, Mars goes through it every couple of years, Venus more frequently, and during those periods spacecraft communication can be interrupted, observation campaigns pause, and we simply accept that there are windows when the sun's glare makes certain objects temporarily invisible. It's Astronomy 101 standard orbital mechanics, nothing remotely suspicious about it, except the timing. October 21st, 2025, the exact date when 3i Atlas reached perfect conjunction, hiding behind our star at the moment when NASA activated its Planetary defense protocol, when unverified whistleblower claims emerged, when Stephen Burns's predicted CME was calculated to impact, and the conjunction period extends from mid-October through mid-November, encompassing perihelion on October 29th, when the comet passes just zero. 19 astronomical units from the sun's surface, closer than Mercury ever gets, subjected to temperatures exceeding 1000 degrees Celsius and radiation that would sterilize any biological material known to science. Everything interesting, everything extreme, everything that might trigger behavioral changes revealing the object's true nature, happens during the 4 weeks when Earth-based observation is impossible. Dr. Avi Loeb addressed this timing explicitly in his October 22nd article. He noted, and again I encourage you to read the original for full context, that perihelion passages are when comets reveal their composition most dramatically, when solar heating reaches maximum intensity, when outgassing peaks, when structural integrity is tested to its limits. If an object is going to fragment, it typically happens near perihelion when thermal stress is greatest. If unusual materials are present, materials that respond to heat or radiation in non-standard ways, perihelion is when those responses become observable. The fact that 3i Atlas's perihelion occurs during solar conjunction means the most scientifically valuable observation period happens when we're effectively blind, dependent entirely on space-based instruments that aren't designed for comet observation and whose data won't be publicly released for months. Loeb raised another intriguing possibility that sounds like science fiction, but is actually grounded in real orbital mechanics, the Oberth effect. This is a principle discovered by Hermann Oberth, one of the founding fathers of rocketry, which states that a propulsive maneuver performed deep in a gravity well is more efficient than the same maneuver performed in open space. In practical terms, if you're a spacecraft and you want to change your velocity significantly, the optimal place to do it is at perihelion, when you're moving fastest and closest to the Sun, because the same amount of thrust produces a larger velocity change due to the way kinetic energy scales with speed. It's why space missions often use close planetary flybys for gravity assists, borrowing energy from the planet's motion to boost their own trajectory. Now apply that principle to 3I Atlas. If, and I'm speaking purely hypothetically here, if this object had any capability to alter its trajectory, any form of propulsion, whether natural or artificial, perihelion would be the moment to use it. A small thrust applied at perihelion, when the object is moving at maximum velocity, would produce trajectory changes far larger than the same thrust applied anywhere else in its orbit, and conveniently that moment occurs when we can't observe it, when any burn or maneuver or activation would be hidden behind the Sun's glare, undetectable until the object emerges, and we can compare its actual trajectory to the predictions made before conjunction. If there's a deviation, if the comet doesn't appear exactly where pure gravitational models say it should, we'd only discover that discrepancy in late November, when ground-based tracking resumes. I want to be clear, there's no evidence that 3I Atlas has propulsion. The Oberth maneuver scenario is speculation, a thought experiment exploring what would be possible if someone wanted to alter an object's course while minimizing detectability. But it illustrates why the timing matters, why having perihelion occur during solar conjunction creates an information gap that, whether by chance or design, provides maximum concealment during the period of maximum activity. There's also the fragmentation possibility, which Loeb discussed as a more conventional explanation for potential trajectory changes. Comets do fragment, sometimes spectacularly. Comet Shoemaker-Levy 9 broke into multiple pieces before colliding with Jupiter in 1994. Comet Linear disintegrated completely during its 2000 perihelion passage. When a comet fragments, the pieces separate and follow slightly different trajectories, creating what looks like non-gravitational acceleration, because suddenly you have multiple objects where there used to be one, and observers tracking the brightest fragment might not immediately realize they're no longer following the original nucleus. If 3I Atlas fragments during its hidden perihelion passage, we won't know until it emerges, and observers notice that the object appears different, perhaps showing multiple nuclei or an unusually extended debris field. Here's what makes fragmentation particularly interesting as a cover mechanism. It's completely natural, well documented, and provides a ready-made explanation for almost any anomaly that might be observed post-conjunction. Trajectory deviations, fragmentation altered the mass distribution, brightness changes, fragmentation exposed fresh icy material, structural anomalies, fragmentation in progress. It's an all-purpose explanation that would allow any unusual observations to be categorized as interesting but not alarming, reducing them to a known phenomenon rather than evidence of something unprecedented. The European Space Agency's JUICE probe adds another layer to this hidden observation period. JUICE, short for Jupiter Icy Moons Explorer, is a spacecraft currently on its way to Jupiter, scheduled to arrive in 2031 to study Europa, Ganymede and Callisto. But long-term space missions often include science observations during the cruise phase, opportunities to gather data on targets of interest that happen to be visible from the spacecraft's unique vantage point. On November 4th, 2025, JUICE is scheduled to conduct observations of 3I Atlas using its MAGIS instrument, an imaging spectrometer designed specifically to analyze the composition of icy bodies. November 4th is 6 days after perihelion, when the comet will have survived maximum solar heating but still be too close to the Sun for ground-based observation from Earth. JUICE's position in space gives it an angle that Earth doesn't have, potentially allowing it to observe the comet while it's still in our observational blind spot. But here's the critical detail. JUICE data won't be publicly released until February 2026, a full 3 months after it's collected. The official explanation is standard data processing, calibration, analysis, peer review, all the normal procedures that scientific missions follow before publishing results. But 3 months is a long time in the context of fast-moving events. By February 2026, 3I Atlas will be long past its closest approach to Earth, will have faded from public attention, and any surprising findings will be announced in the calm, measured context of peer-reviewed publication rather than the immediate urgency of breaking news. If JUICE observes something unusual on November 4th, authorities will have 3 months to prepare the narrative, contextualize the findings, and ensure that when the information becomes public it's presented in ways that minimize alarm and speculation. Let me draw a parallel from history, because some of you will remember this. During the Cold War, there were incidents, aerial observations, radar contacts, events that suggested something unexplained was occurring, and the information was classified not necessarily because it revealed alien activity, but because revealing it would expose surveillance capabilities, intelligence-gathering methods, or simply because officials didn't have good explanations and admitting ignorance would undermine public confidence in institutions. The information eventually came out, sometimes decades later, often revealing that the mystery was more mundane than feared, but also showing that the secrecy had been maintained not for public safety, but for institutional control of narratives. We're watching that pattern repeat in slow motion with 3I Atlas. The object goes dark during its most critical phase, hidden by the sun in a way that appears completely natural and coincidental, but creates a convenient information gap. Space-based assets might observe during this period, but their data is controlled, delayed, filtered through review processes that ensure nothing reaches the public without institutional vetting. When the object emerges in late November, any anomalies can be attributed to unobserved events during conjunction, fragmentation, or outbursts or natural processes that happened when we couldn't watch. It's the perfect setup for maintaining ambiguity, for keeping explanations flexible, for ensuring that no single observation becomes definitive proof of anything that would demand uncomfortable responses. October 29th is significant in another way that probably means nothing, but feels symbolically appropriate. Perihelion occurs 2 days before Halloween, a date that Western culture associates with the thinning of veils between worlds, with hidden things becoming visible, with traditions of acknowledging that reality might contain elements we don't fully understand. Ancient cultures would have seen an interstellar visitor reaching its closest solar approach on such a date as an omen, a sign, a moment when the cosmos was trying to communicate something. We're more rational now, we understand orbital mechanics and don't assign mystical significance to dates, but there's still something deeply human about noticing patterns, about seeing coincidences and wondering whether they're truly random, or whether some deeper structure is playing out that we only glimpse fragments of. The sun hides many things. Solar physicists joke that the best place to hide a spacecraft would be in orbit close to the sun, where the glare makes detection nearly impossible, and where thermal conditions would disguise most signatures that tracking systems rely on. Whether by chance or intention, 3I Atlas is hidden there now, undergoing its closest approach to our star, experiencing conditions that could reveal its secrets or create new mysteries, all while we wait on the outside, watching the calendar, counting down to November 27th when the veil lifts and we finally get to see what emerged from behind that fire. But while we wait for that reveal, there's something we can examine right now, something already observed and documented, something that makes even skeptical scientists pause and admit that this object doesn't fit the models we've relied on for understanding what comets should be. When you analyze light from a distant object, you're essentially performing cosmic archaeology, decoding messages written in wavelengths that reveal the object's chemical composition with remarkable precision. Every element, when heated or energized, emits light at specific wavelengths, creating a unique signature as distinctive as a fingerprint. Astronomers call this spectroscopy, and it's one of the most powerful tools in the scientific arsenal for understanding what things are made of without ever physically touching them. Point a spectrograph at a star, and those wavelengths tell you whether it contains hydrogen, helium, calcium, iron. Point it at a comet, and you learn whether it's made of water ice, carbon dioxide, silicate dust, organic molecules. It's precise, reliable, refined over centuries of observation and laboratory calibration. When spectroscopy reveals something unexpected, something that doesn't match the catalogue of known signatures, astronomers pay attention because it means either their instruments are malfunctioning or the universe is showing them something new. 3I Atlas was observed spectroscopically multiple times during August, September and October 2025, using some of the most advanced instruments available to science, the Keck Observatory in Hawaii, the Very Large Telescope in Chile, and the Gemini Observatory. These aren't amateur backyard setups. These are facilities that cost billions of dollars collectively, staffed by professionals who spend their entire careers perfecting observation techniques. And across multiple observations, multiple instruments, multiple independent teams, they all saw the same thing: strong emission lines corresponding to nickel appearing at wavelengths that unambiguously identify that element, with an intensity that indicates significant abundance. Nickel in a comet isn't inherently mysterious. Comets contain dust grains formed in the primordial solar nebula, and those grains include metal particles, nickel and iron, being among the most common metals in cosmic abundance. You expect to see some metal signatures in comet spectra. But here's what stopped researchers and triggered extensive discussion in professional forums. The ratio was wrong. When you observe metal grains in comets or asteroids or meteorites, you expect to see nickel and iron together in proportions that reflect how these elements exist in nature, how they formed in stars and were incorporated into the building blocks of solar systems. Iron is far more abundant than nickel in cosmic material, typically outnumbering nickel by roughly 10 to 1. So when you see nickel lines in a spectrum, you should also see iron lines, and the iron should be significantly stronger. But 3i Atlas showed prominent nickel emission with iron lines either absent or far weaker than standard models predict. That's not how natural mineral grains work. That's not how cosmic metal abundances are supposed to look. It's like analysing a rock and finding it's made entirely of zinc without the copper or iron that should accompany it. A ratio that would make geologists deeply confused because nature doesn't fractionate elements that way, without very specific, unusual processes. Dr. Avi Loeb discussed this nickel anomaly in his recent articles, noting that one possible explanation involves nickel tetracarbonyl, a compound with the chemical formula nickel tetracarbonyl. This is a substance that, on Earth, is primarily associated with industrial processes, specifically the Mond process developed in the late 19th century for purifying nickel metal. Nickel tetracarbonyl is created when carbon monoxide reacts with nickel at moderate temperatures, producing a volatile compound that was historically used in metallurgy before being largely phased out due to its extreme toxicity. It's one of the most poisonous substances known, lethal in concentrations of just a few parts per million, which is why modern nickel refining uses different methods. But the reason it matters for 3i Atlas is that nickel tetracarbonyl could potentially form in space under specific conditions, and if present, it would vaporize when heated by sunlight, releasing nickel atoms into the coma without corresponding iron, creating exactly the spectroscopic ratio that observers are seeing. Now, does the presence of nickel tetracarbonyl mean the comet is artificial, some kind of industrial probe from an advanced civilization? Absolutely not, and that's not what any serious scientist is claiming. What they're saying is that the nickel-to-iron ratio is unusual, that it requires explanation, and that one possible explanation involves a compound that terrestrially is associated with industrial chemistry, but could form naturally in interstellar space if the conditions were right. Interstellar clouds contain carbon monoxide, one of the most abundant molecules in space. They contain dust grains with nickel. If those ingredients come together in the right environment, with the right temperatures and pressures, chemistry happens. Whether that chemistry can produce nickel tetracarbonyl in quantities sufficient to explain the observed nickel abundance in 3i Atlas is a question that requires detailed modelling, laboratory experiments, and careful analysis. It's an active area of investigation, not a settled conclusion. But here's why this matters beyond the technical details. It represents a pattern. 3. I-Atlas doesn't just have one weird characteristic. It has multiple anomalies, each individually explainable through creative application of known physics, but collectively suggesting that this object is pushing the boundaries of what standard comet models can accommodate. The nickel ratio is one piece. The trajectory deviation mentioned in the IAWN bulletin is another. The brightness offset discussed earlier is a third. The unverified gamma ray claims, if true, would be a fourth. When you're evaluating whether something is genuinely unusual or just an interesting outlier, you look at the totality of evidence. Any single anomaly can be dismissed as measurement error, natural variation, or incomplete understanding. But when multiple independent anomalies appear in the same object, each requiring its own special explanation, scientists start to wonder whether they're missing a larger pattern, whether the object is trying to tell them something that current theories aren't equipped to hear. Loeb has been particularly vocal about the need to take interstellar objects seriously as potential technosignatures, artificial objects created by other civilizations that might pass through our solar system carrying information about their creators. He's proposed missions to catch up with Oumuamua, the first interstellar visitor discovered in 2017, which exhibited its own set of unexplained accelerations and characteristics. He's argued that dismissing these anomalies without thorough investigation represents a failure of scientific curiosity, a preference for comfortable explanations over uncomfortable possibilities. And with 3i Atlas, he's applying the same principle. Look at the evidence without preconceptions, admit when models don't fit observations, and be willing to consider explanations that might challenge our assumptions about what's natural and what's not. The spectroscopic observations will intensify as the comet becomes visible again in late November. When an object is brighter and better positioned for observation, spectrographs can gather higher resolution data, detecting fainter spectral lines and providing more detail about chemical abundances. If the nickel signature persists or strengthens as the comet approaches Earth in December, if additional emission lines appear that further complicate the compositional picture, if the ratio of nickel to iron remains stubbornly inconsistent with natural minerals, then researchers will have to decide how much creative explanation they're willing to apply before admitting that maybe, just maybe, this object's composition genuinely doesn't match anything we've seen before in comets. I want to emphasize again, unusual composition doesn't equal alien technology. The universe is vast, the chemistry of interstellar space is complex, and objects from other star systems might have formed in environments with different elemental abundances, different thermal histories, different chemical processes than the solar system materials we're familiar with. Finding something that doesn't match solar system norms doesn't mean it's artificial. It means it's from somewhere else, formed under different conditions, carrying the chemical signature of a stellar environment that might be very unlike our own sun's neighborhood. That alone makes it precious, scientifically invaluable, worth every hour of telescope time and every bit of analysis effort. But there's a difference between scientific caution and willful blindness. There's a difference between saying this could have natural explanations we haven't thought of yet, and saying this is definitely natural and requires no special attention. The first is good science, staying open while demanding evidence. The second is dogma, deciding the answer before examining all the data. And when organizations activate planetary defense protocols, when observation campaigns are coordinated internationally, when data delays ensure that information is carefully controlled before reaching public awareness, it suggests that people with access to more data than we have are treating this object as something that warrants exceptional attention, regardless of what their public statements say. And the nickel enigma is just one entry in a catalogue of strangeness that, taken together, creates a picture that even conservative scientists admit is deeply puzzling. In science, anomalies are the cracks where new understanding emerges, the observations that don't quite fit existing theories, the data points that make you question whether your models are complete or whether nature is showing you something your framework wasn't designed to accommodate. Individual anomalies can often be explained away: measurement error, unusual but natural variation, coincidence. But when multiple anomalies cluster in a single object, when explanations for one anomaly don't address the others, when the cumulative improbability starts to feel less like coincidence and more like pattern, that's when scientists stop saying interesting outlier and start saying we need to fundamentally reconsider what we're looking at. 3i Atlas presents at least 8 distinct anomalies, each documented through professional observations, each requiring its own explanation, and collectively forming a profile that Dr. Avilob has rated at approximately 4 on his proposed scale for assessing the artificiality of interstellar objects, a scale where 1 represents definitely natural and 10 represents definitely artificial. A 4 doesn't mean alien probe. It means sufficiently unusual that artificial origin can't be dismissed without thorough investigation. Unusual enough that scientific caution demands we keep that possibility on the table, even if we expect natural explanations to ultimately prevail. Let me walk you through these puzzles one by one, and you can judge for yourself whether the explanations feel adequate or whether something deeper is being missed. First, the orbital alignment. 3i Atlas entered our solar system from interstellar space, but its trajectory brought it remarkably close to the plane of the ecliptic, the flat disk where Earth and the other planets orbit. Statistically, objects entering from random directions in 3-dimensional space should arrive at random angles. Most should come in well above or below the ecliptic plane because there's no reason for interstellar objects to preferentially target that specific alignment. Yet 3i Atlas arrived nearly edge-on to the ecliptic, which meant its path brought it through the inner solar system where planets are concentrated rather than passing above or below, where it would interact with nothing. Natural. Certainly possible. Random chance does produce unlikely outcomes. But it's the first data point in our pattern, the first indication that this object's path seems almost designed to maximize interaction with our planetary system. Second, the anti-tail. Typical comets develop tails pointing away from the Sun, pushed outward by solar wind and radiation pressure. But observations of 3i Atlas in September and early October showed a faint anti-tail, material appearing to point toward the Sun, opposite the expected direction. Anti-tails aren't unknown in cometary science. They occur when larger, heavier dust particles follow different trajectories than the fine material that forms the main tail, creating projection effects where from certain viewing angles the tail appears to point sunward. But the persistence and structure of 3i Atlas's anti-tail, as documented in images from amateur and professional observers, showed characteristics that some researchers noted don't perfectly match standard projection effects. It suggests either unusual particle size distribution, or material being released in directions that simple outgassing models don't predict. Third, the size estimates. Based on brightness and assumptions about reflectivity, astronomers initially estimated 3i Atlas's nucleus at somewhere between 1 and 4 kilometers in diameter. But as more data accumulated, those estimates became increasingly uncertain because the object's brightness didn't follow the standard relationship between size, distance, and reflectivity that comets usually obey. Some models suggested a smaller nucleus, maybe just a few hundred meters, that was unusually active, producing far more coma for its size than typical comets. Other models suggested something larger, but with unusual surface properties, perhaps higher reflectivity or patchy activity concentrated in specific areas. The inability to pin down a reliable size estimate from brightness data alone suggests that whatever assumptions about surface properties are being applied don't quite match reality, another small discrepancy that individually means little but adds to the pattern. Fourth, the multiple close planetary flybys. As 3i Atlas's trajectory was refined, astronomers calculated that its path would bring it remarkably close to several solar system bodies in sequence. It passed near Earth's orbit in July 2025. It reached perihelion in October. December 19th marks its closest approach to Earth at 0.6 astronomical units. And in March 2026, it's scheduled for a close flyby of Jupiter, passing near enough that the giant planet's gravity will significantly alter the comet's outbound trajectory. For a single object to have multiple close encounters with major bodies in our system is, again, not impossible, but statistically uncommon. It's like threading a needle multiple times in sequence. Natural orbits do it, but the more encounters you rack up, the more it looks less like random trajectory and more like a path calculated to tour the system's major landmarks. Fifth, we've already discussed the nickel-ion ratio, but it bears repeating as part of this catalogue. Spectroscopic data showing strong nickel with weak iron defies the standard cosmic abundance ratios and requires special explanations involving either unusual chemistry or unusual source material. It's a compositional fingerprint that doesn't match the typical cometary profile, another checkmark in the unusual column. Sixth, the water content, or rather the puzzling analysis thereof. Early spectroscopic observations attempted to measure water vapor production, the standard diagnostic for cometary activity since comets are supposed to be primarily water ice. But the water signature detected in 3i Atlas was weaker than expected for an object showing the level of activity evidenced by its coma and tail. Either the comet is unusually dry, composed less of water ice than typical solar system comets, or the activity is being driven by other volatile compounds, carbon monoxide or carbon dioxide perhaps, that vaporize more readily than water and could be more abundant than normal. Either scenario suggests an object formed in a different chemical environment, potentially around a star with different composition than our Sun, but it adds another layer of doesn't quite match expectations to the growing list. Seventh, polarization measurements. Light reflected from a comet's coma is partially polarized, meaning the light waves oscillate preferentially in certain directions rather than randomly. The degree and orientation of polarization tell you about the size and composition of the dust particles scattering the light. Observations of 3I Atlas showed polarization characteristics that, according to some preliminary analyses discussed in professional forums, didn't perfectly match standard comet dust models. The discrepancy wasn't enormous, but it suggested either unusual dust composition or unusual particle size distribution, yet another small deviation from the standard profile. Eighth, the directional coincidence. This one is speculative and depends on accepting the unverified gamma-ray claims, but it's worth noting for completeness. 3I Atlas entered our solar system from a direction that, when traced backward into interstellar space, comes from a region of the sky not far from where the famous WOW signal was detected in 1977, a radio signal received by SETI researchers that remains one of the few genuinely unexplained radio detections in the history of the search for extraterrestrial intelligence. The WOW signal lasted 72 seconds, showed characteristics suggesting an artificial narrowband transmission, and came from the constellation Sagittarius. No repeat signal was ever detected despite extensive follow-up searches. 3I Atlas's origin direction is also in Sagittarius, not identical to the WOW, signals coordinates but within the same general region of sky. Coincidence? Almost certainly, given how large the constellation Sagittarius is and how many stars occupy that region. But it's another detail that conspiracy theorists latch onto, another element that feeds speculation even if the scientific significance is minimal. Taken individually, each of these anomalies has possible natural explanations. Ecliptic alignment is just lucky trajectory. Anti-tails are projection effects. Size uncertainty reflects incomplete data. Multiple flybys are statistically uncommon, but not impossible. Nickel ratio could be unusual chemistry. Low water could be unusual formation environment. Polarization discrepancies could be measurement uncertainty. Directional coincidence with WOW is meaningless pattern recognition. You can explain each one away if you work at it, but consider the cumulative picture. You have an interstellar object arriving at an unusual angle, with unusual composition, unusual activity patterns, unusual spectroscopic signatures, traversing an unusual path that brings it near multiple planets, behaving in ways that require creative explanations at every turn, and doing all of this while activating planetary defense protocols and generating enough institutional attention that coordinated international observation campaigns are being prepared. At what point does unusual but natural become this deserves extraordinary scrutiny? At what point do we admit that while each puzzle piece might have a mundane explanation, the completed puzzle shows a picture we're not quite prepared to acknowledge? Dr. Loeb has argued that this is precisely the kind of object that justifies his proposal for systematic investigation of interstellar visitors using dedicated spacecraft capable of close-up observation, spectroscopy, and even sample return. He's not claiming 3I Atlas is definitely artificial. He's claiming it's sufficiently anomalous that definitive answers require better data than ground-based telescopes can provide, and that defaulting to natural explanations without gathering that better data represents intellectual laziness rather than scientific rigor. We're going to get more data. November 27th starts the observation window. December 19th provides closest approach. January extends the tracking period. By the time March 2026 arrives with the Jupiter flyby, we'll have months of intensive observations, more spectroscopy, more astrometry, more data points either confirming that this is just an unusual comet or revealing that the anomalies deepen rather than resolve under scrutiny. But there's one explanation that ties all these puzzles together, one hypothesis that would make every anomaly suddenly make sense, and it's the explanation that makes institutions most nervous because it demands answers to questions we're not sure we want to ask. Let me introduce you to one of the most haunting ideas in modern thinking about extraterrestrial life. It's called the dark forest hypothesis, popularized by Chinese science fiction writer Liu Cixin in his Remembrance of Earth's Past trilogy, but rooted in serious attempts to resolve the Fermi paradox, the troubling question of why we see no evidence of alien civilizations despite the staggering number of potentially habitable planets in our galaxy. The reasoning goes like this. The universe is like a dark forest, and every civilization is a hunter moving through the trees, armed and alert. Broadcasting your presence, sending signals into space, Revealing your location is the act of a naive species that doesn't understand the fundamental danger of the situation. Because if there are other hunters in the forest, and if they're more advanced than you, they face a simple strategic calculation. Eliminate potential competitors before those competitors become threats. It's cosmic game theory taken to its darkest conclusion, suggesting that intelligent civilizations survive not by communicating but by hiding, not by reaching out but by ensuring no one knows they're there until it's too late for anyone else to do anything about it. The dark forest hypothesis offers one answer to the Fermi paradox, the great silence, the fact that our telescopes and radio dishes hear nothing but natural noise despite decades of searching. Perhaps advanced civilizations aren't silent because they don't exist. Perhaps they're silent because they learned that survival requires silence, that the universe isn't empty, but rather filled with watchers, and revealing yourself is survival-level foolish. It's a deeply paranoid vision of the cosmos, replacing Star Trek's optimistic Federation with a Hobbesian struggle, where every species is fundamentally alone and threatened. Now apply that framework to interstellar objects passing through our solar system. If you were an advanced civilization wanting to reconnoiter potential threats or targets, you wouldn't announce your arrival. You wouldn't send spacecraft with blinking lights and friendly radio greetings. You'd send probes designed to look natural, to blend in with the countless asteroids and comets that populate interstellar space. Objects that could pass through a solar system gathering data without triggering alarm. The probes wouldn't need to be large or obviously technological. They'd need to be smart, equipped with sensors and enough intelligence to observe, record, and transmit findings back across interstellar distances using methods we might not recognize as communication. And if you wanted to know whether a particular star system harbored civilizations approaching technological maturity, civilizations that might one day become competitors or threats, you'd want to observe how they react to unusual objects, whether their science is sophisticated enough to detect anomalies, whether their defensive capabilities warrant concern. Dr. Avi Loeb has written about this possibility, not as his preferred explanation, but as a hypothesis that can't be completely dismissed given our current understanding of what's possible and what we've observed. He notes that if even a tiny fraction of interstellar objects are artificial probes, if even 1 in a million objects passing through solar systems is designed by intelligence rather than formed by nature, then statistically we should have been visited many times throughout Earth's history. Most would pass unnoticed, mistaken for natural bodies if observed at all, completing their reconnaissance and departing without anyone realizing that what they saw was anything other than a rock from another star. But occasionally one might exhibit characteristics that observant scientists notice, behaviors that don't quite fit natural models, signatures that make thoughtful people wonder whether their assumptions about what's natural might be incomplete. Oumuamua, the first interstellar object discovered transiting our solar system in 2017, exhibited exactly these kinds of troubling characteristics. It accelerated away from the Sun faster than gravity alone could explain, requiring some form of additional force to account for the trajectory deviation. The standard explanation was outgassing, just like comets, but Oumuamua showed no visible coma, no tail, none of the dusty signature typical of active comets. It also tumbled in an unusual pattern and had an extremely elongated shape, either a long cigar or a flat pancake depending on which models you trust. Loeb has argued, controversially, that Oumuamua's characteristics are consistent with it being a light sail, a thin, reflective surface pushed by radiation pressure, technology that we're beginning to develop ourselves for interstellar missions. The astronomical community largely rejected that interpretation, preferring natural explanations involving comets made of exotic ices that don't produce visible dust. But the debate highlighted how uncomfortable mainstream science becomes when asked to seriously consider artificial explanations for observations that don't quite fit natural models. 3. iAtlas is different from Oumuamua in many ways. It shows clear cometary activity, a visible coma and tail, spectroscopic signatures of vaporizing materials. Nobody is arguing it's a light sail. But it has its own catalogue of anomalies, different puzzles that require different creative explanations, and collectively they raise the same uncomfortable question. At what point do we take seriously the possibility that some interstellar visitors might not be natural debris but designed objects sent to study us? If the unverified gamma-ray claims were true, if 3i Atlas were emitting periodic high-energy radiation that no natural comet process explains, that would shift the conversation dramatically. Gamma rays require extreme energy generation, the kind associated with nuclear processes or exotic physics that don't occur in cold ice and rock. A periodic gamma ray signature would suggest an energy source, something generating power, something active rather than passive. That moves the object from unusually behaving comet into we don't know what this is territory that demands immediate intensive investigation. But even without gamma rays, even taking only the verified observations, the spectroscopic anomalies, the trajectory uncertainties, the timing of IAWN activation during solar conjunction, there's enough smoke to justify looking for fire. The dark forest hypothesis predicts exactly this kind of strategic ambiguity, where reconnaissance assets are designed to maintain plausible deniability, to look natural enough that any civilization observing them can choose to interpret what they see as natural phenomena rather than confront the uncomfortable implication that they're being watched. You've lived long enough to remember paranoia that turned out to be justified. You remember when people who suspected governments were conducting mass surveillance were dismissed as conspiracy theorists, until Edward Snowden revealed that yes, in fact, your phone calls and emails were being collected in bulk. You remember when questioning official narratives was considered unpatriotic or crazy, until declassified documents proved that yes, officials had lied, experiments had been conducted without informed consent, surveillance had been widespread. Paranoia isn't always wrong. Sometimes the world really is darker than the comforting stories we're told. The question isn't whether you should panic about 3i Atlas representing a dark forest probe. The question is whether you're willing to consider the possibility seriously enough to demand that authorities gather better data before defaulting to comfortable natural explanations. Artificial doesn't necessarily mean hostile. A civilization capable of interstellar travel might have no interest in primitive species like us, might be conducting academic surveys rather than military reconnaissance, or the objects might be ancient, sent eons ago by civilizations long extinct, mindlessly continuing missions whose originators no longer exist. Or they might be natural after all, just genuinely unusual comets from stellar environments we don't yet understand, teaching us that our models need revision without implying any intelligence behind them. But we won't know without looking, without investigating with the same rigour we'd apply if a strange aircraft were detected in restricted airspace, without demanding better answers than probably just natural, probably nothing to worry about. Trust us to handle it quietly. The observation window opening November 27th represents humanity's chance to either confirm this is an unusual but natural comet, or gather evidence compelling enough that even conservative institutions have to admit the situation warrants more than business as usual analysis. And that observation window, carefully scheduled, precisely timed, represents the moment when hidden truths might finally become visible to anyone paying attention. Mark your calendars, because the dates ahead matter more than perhaps any astronomical observation period in recent history. We're not talking about eclipses or meteor showers, predictable celestial events that happen regularly and delight amateur sky watchers. We're talking about a window of scientific investigation that will either confirm 3i Atlas as an interesting but ultimately natural interstellar comet, or reveal anomalies significant enough to force reconsideration of what's possible, what's natural, and what might be traversing the space between stars. The timeline is set, the instruments are being prepared, the observation protocols are established, and in just weeks we're going to start seeing data that's been hidden behind the sun for the entire period, when solar forces could have triggered changes that reveal this object's true nature. November 4th, 2025 is the first critical date. That's when the European Space Agency's JUICE spacecraft, currently on its long journey to Jupiter, will turn its instruments toward 3i Atlas and capture observations using equipment specifically designed to study icy bodies. JUICE carries MAGIS, an imaging spectrometer that can analyze the chemical composition of surfaces and atmospheres with precision that ground-based telescopes can't match, because space-based instruments don't have to peer through Earth's atmosphere, which filters and distorts the very wavelengths scientists need to see. JUICE's observation will occur just 6 days after perihelion, when the comet will have survived its closest approach to the Sun, but still be too close to the Sun in our sky for ground-based observation from Earth. JUICE has a different vantage point, positioned such that the Sun-Comet spacecraft angle allows observation that our planet can't achieve. What will JUICE see? If the comet is behaving normally, JUICE will observe strong water signatures, possibly carbon dioxide and carbon monoxide. dusty coma with particle sizes matching typical cometary dust, brightness consistent with natural outgassing patterns. The data will be interesting, scientifically valuable for comparison with other comets, but ultimately routine. But if the comet is exhibiting any of the speculated unusual behaviours, if there's unexpected composition, if the coma structure shows asymmetries or features that don't fit standard outgassing models, if brightness suggests structural changes happen during perihelion, JUICE's instruments will capture it in detail that can't be dismissed as ground-based observation artifacts. Here's the challenge. We won't see that JUICE data until February 2026. 3 months of delay while the data is downloaded, processed through calibration pipelines, analysed by mission scientists, contextualised, interpreted, and finally prepared for publication. That delay is normal for space missions, standard operating procedure, but it also means that if JUICE observes something surprising on November 4th, authorities will have 3 months to decide how to present those findings, whether to release raw data immediately, or wait for comprehensive analysis, whether to emphasise surprising elements or frame everything in reassuring natural explanations. By February, the comet will be long past its closest approach, public attention will have moved on, and whatever JUICE reveals can be published in careful scientific language that avoids alarm. November the 27th, 2025, is when ground-based observation finally becomes possible again. That's when 3i Atlas will be far enough from the sun in our sky that professional observatories can point their instruments without being blinded by solar glare. The IAWN observation campaign officially begins that day, with participating observatories worldwide starting their coordinated astrometry program, precisely measuring the comet's position night after night to track its trajectory with accuracy sufficient to detect any non-gravitational forces affecting its motion. For 2 months from late November through late January, this will be one of the most intensively observed comets in history, studied not because it's particularly bright or spectacular, but because it's interstellar, unusual, and apparently concerning enough to warrant planetary defense attention. What should observers look for? First, position. Does the comet appear exactly where pure gravitational models predict? Or is there a discrepancy suggesting that forces other than gravity are affecting its path? Even small deviations, fractions of an arcsecond in angular position, can indicate outgassing forces, fragmentation, or in more exotic scenarios, propulsion. Second, brightness. Does the comet brighten and fade in predictable patterns based on distance and outgassing, or are there unexpected surges or dips suggesting unusual activity? Third, structure. Does the coma maintain typical symmetry, or are there jets, fans, asymmetries that indicate localized active regions? Fourth, spectroscopy. Do the chemical signatures remain consistent with what was observed before solar conjunction, or have new emission lines appeared suggesting that perihelion heated materials that weren't previously active? December 19th, 2025 is the grand finale of this observation sequence. That's when 3i Atlas reaches its closest approach to Earth, approximately 0.6 astronomical units away, roughly 56 million miles. At that distance, even moderately sized amateur telescopes should be able to spot the comet as a faint fuzzy patch in the pre-dawn sky, and professional observatories will gather their highest resolution data, capturing spectra detailed enough to identify trace compounds, imaging sharp enough to resolve structure in the inner coma, photometry precise enough to detect subtle variations. If there's a smoking gun, a piece of evidence so compelling that even conservative skeptics have to admit something unprecedented is happening, December 19th is when it will most likely reveal itself. But there's also the possibility of fragmentation. Comets are fragile, held together more by their own weak gravity than by structural strength, and perihelion passages subject them to enormous thermal stress. If 3i Atlas was going to break apart, perihelion was the time for it to happen. Observers in late November will be looking for signs that the single nucleus has split into multiple pieces, that the object now shows multiple condensations instead of one central brightness peak, that the tail exhibits complexity suggesting separate fragments releasing material independently. Fragmentation would be scientifically fascinating, providing insight into the internal structure and mechanical strength of interstellar material. It would also provide a convenient natural explanation for any trajectory anomalies, since fragmented objects can appear to deviate from predicted paths as observers inadvertently switch between tracking different fragments. There's precedent for dramatic changes during perihelion. Comet Eason in 2013 was predicted to be the comet of the century, expected to emerge from its extremely close perihelion passage, brilliantly bright and visible in daylight. Instead, it disintegrated completely, either vaporized by solar heating or torn apart by tidal forces, emerging as a dispersing cloud of debris rather than a coherent nucleus. If 3I Atlas follows Ison's fate, observers in late November will see a diffuse fading smudge rather than a distinct comet, and the story ends with a natural, well-understood conclusion about the limits of structural integrity for small icy bodies. But if 3I Atlas emerges intact, if it's still coherent and active, if it's brighter or behaving differently than pre-conjunction models predicted, if the spectroscopy shows changes that suggest composition isn't what was initially thought, then the 2-month observation window becomes a race to gather enough data to either confirm natural explanations or build a case that something more exotic is occurring. January 27, 2026 marks the official end of the Yoon observation campaign. By then, 3I Atlas will be receding rapidly from the inner solar system, its brightness fading as it moves toward Jupiter, and ground-based tracking will become increasingly difficult. But the comet's journey doesn't end there. March 2026 brings another significant event, a relatively close flyby of Jupiter, passing near enough to the giant planet that gravitational perturbations will measurably alter the comet's trajectory. That Jupiter encounter provides one more opportunity for observation, one more chance to see whether the object behaves as pure gravitational models predict or exhibit surprises. Space missions have observation windows, periods when planetary alignments and spacecraft trajectories create opportunities that won't recur. The November to December window for 3I Atlas is exactly that. A brief alignment when the comet is close enough to Earth for detailed study, but far enough from the Sun to be observable, when its post-perihelion state reveals whatever changes that extreme environment triggered, when humanity's telescopes can focus on this visitor before it races back into the interstellar darkness it came from. Miss this window, and we'll never have another chance. The object will fade, recede, and eventually become too distant and too faint for any instruments we possess to study with useful detail. You're going to want to follow this story as it unfolds, whether you're casually interested in space or deeply committed to understanding mysteries at the edge of human knowledge. The next few months offer something genuinely rare, a chance to watch science in action as it grapples with an object that doesn't quite fit the theories, as institutions balance public communication with their desire to avoid causing alarm, as data accumulates and forces decisions about whether comfortable explanations remain adequate or whether something more profound demands acknowledgement. The countdown is real, the observations are scheduled, and whatever emerges from behind that sun in late November is going to tell us whether our assumptions about what's natural and what's possible need fundamental revision. We've reached the moment where all threads converge, where months of build-up, speculation, and careful observation protocols come together in a single profound question. What is 3I Atlas really? Is it a chunk of primordial ice and dust from another star system, interesting but ultimately explicable through natural processes we already understand? Is it something more exotic, a comet formed in chemical environments so different from our solar system that its composition challenges our assumptions about what's typical versus what's possible? Or, in the possibility that makes institutions most nervous and conspiracy theorists most excited, could it be something that no purely natural explanation can adequately account for, something designed, something sent, something that forces humanity to confront that we're not alone and perhaps not unobserved? Let me be absolutely clear about where the evidence stands as I record this. Nothing, absolutely nothing currently proven and verified, demands an artificial explanation. Every anomaly we've discussed has potential natural explanations. Orbital alignment could be coincidence. Spectroscopic oddities could reflect unusual but natural chemistry. Trajectory uncertainties could be standard outgassing effects. The IAWN activation could be appropriate caution for an unusual object without implying hidden threats. We can construct a narrative where 3I Atlas is simply an interesting interstellar comet, unusual but ultimately natural, teaching us that objects from other star systems don't necessarily match solar system norms, but not revealing anything that challenges our fundamental understanding of what comets are. But here's what I find troubling, and I suspect you do too if you've stayed with me this long. The silence, the careful control of information, the delayed data releases, the coordination of observation protocols that screen who can contribute to the official record, the timing of everything happening during a period when the object is conveniently invisible, the patterns that keep accumulating where official statements say one thing but actions suggest different levels of concern. You don't live 7 decades on this planet without developing instincts for when you're being told the comfortable version of a story rather than the complete truth. Think about what we've established as facts, verifiable through public records that anyone can check. NASA and international partners activated a planetary defense observation campaign on October 21st, published in the Minor Planet Center, targeting an interstellar comet during its solar conjunction and perihelion passage. That activation happened the same day that Stephen Burns predicted a CME impact based on months-old forecasts. The same day an unverified whistleblower post appeared claiming gamma-ray detections. The same day Dr. Avi Loeb published analysis noting that this object warrants intense scrutiny. The observation campaign focuses on astrometry, trajectory tracking, the kind of precision measurement you do when you're concerned an object might not go exactly where models predict. Multiple spectroscopic observations from major observatories documented nickel-to-iron ratios that don't match typical cosmic abundances. The object will be observed by space-based assets during solar conjunction, but that data won't be public for months, and the entire critical perihelion period occurs while we're blind, dependent on delayed reports from instruments we can't access and analyses we can't independently verify. That's not conspiracy theory. That's documented timeline and publicly available information, interpreted through the lens of someone who has watched governments manage public perception during events they don't fully understand or don't want to fully explain. The pattern fits controlled disclosure, gradual release of information calibrated to avoid panic while preparing people for revelations that might challenge comfortable assumptions. Now, does that mean 3i Atlas is definitely artificial? Definitely a probe from a civilization navigating the dark forest of interstellar space? Number. It means the situation warrants the attention it's receiving, and that attention should include public awareness rather than quiet institutional management. If this is just an unusual comet, there's no reason to restrict information or delay data releases beyond standard scientific procedures. If it's something more, if any of the speculated possibilities have merit, then humanity deserves to know rather than being fed carefully curated narratives designed to prevent uncomfortable questions. I want to emphasize that I'm not advocating panic or assuming hostile intent if the object does turn out to be artificial. The universe is vast, containing billions of stars and presumably countless civilizations at various stages of development. If some of those civilizations send probes to study interesting star systems, that's an academic exercise, gathering data, nothing necessarily threatening about it. First contact, even if it occurs through discovery of an unmanned probe rather than direct communication, would be the most profound moment in human history, reshaping our understanding of our place in the cosmos, but not inherently dangerous. The fear that fuels dark forest thinking assumes worst-case hostility, but equally valid scenarios exist where advanced civilizations have moved beyond resource competition and conflict, where reconnaissance is genuine curiosity rather than prelude to conquest. What concerns me isn't the possibility of extraterrestrial observation. What concerns me is institutional reflex to control information, to decide on behalf of billions of people what they're ready to know, what they can handle, what should be revealed versus what should be managed through carefully crafted messaging. That impulse, that paternalistic assumption that ordinary people can't process difficult truths without descending into chaos, has been used throughout history to justify secrecy that ultimately served institutional interests more than public welfare. Sometimes the secrecy was justified, sometimes revealing certain information would have caused unnecessary harm, but often, very often, the secrecy was about avoiding embarrassment, maintaining control, preventing questions that authorities didn't have good answers for. You've earned the right to make your own judgments about what's plausible and what's not. You've seen enough of history to know that official narratives aren't always complete, that authorities sometimes lie and sometimes tell truth, but rarely give you the full picture without pressure. You've developed bullshit detectors calibrated by decades of experience, watching how power operates, how information flows, how institutions behave when they're confident versus when they're uncertain. Trust those instincts. Watch what happens over the next 60 days. Read what's officially stated, but also notice what's carefully not stated. what questions get deflected, what data gets delayed, what explanations feel complete versus what feels like placeholder narratives buying time. November 27th through January 27th is humanity's observation window. During those 2 months, hundreds of professional telescopes will gather data that either confirms natural explanations or reveals anomalies compelling enough to demand serious reconsideration. You won't have access to all that data immediately. You won't see raw observations as they're collected, but you'll see reports, you'll see preliminary findings, you'll see enough to form educated opinions about whether the story adds up or whether pieces are being hidden. I'm asking you to pay attention, follow the news, not just mainstream outlets, but astronomical forums where professionals discuss observations without institutional filters. If you have access to amateur astronomy resources, watch for reports from observers participating in or adjacent to the IAWN campaign. Listen to what's said, but also notice the silence, the topics that get avoided, the questions that don't get asked in official press releases, and most importantly, share information. This is a moment when decentralized attention, thousands of people watching and documenting and comparing notes, makes it harder for any single institution to completely control the narrative. I'm not claiming this is definitely alien technology. I'm saying it's definitely unusual, definitely worthy of attention, and definitely being handled in ways that suggest authorities are treating it as more significant than public statements acknowledge. That gap between official reassurance and actual behaviour is where truth often hides, and closing that gap requires public pressure, demands for transparency, insistence that this story belongs to all of humanity, rather than being quietly managed by institutions that prefer control over disclosure. This channel will continue covering 3i Atlas as new information emerges. I'll be watching those November and December observations, analysing what gets revealed and what gets suppressed, translating technical findings into language that doesn't require astrophysics degrees to understand. If this turns out to be nothing, if natural explanations prove adequate, and the planetary defense activation was simply appropriate caution, I'll be the first to say so. But if anomalies deepen, if observations reveal characteristics that can't be comfortably explained away, if institutional responses become more evasive and defensive, we'll document that too. Subscribe if you want to follow this story as it unfolds. Hit that notification bell so you don't miss updates when significant observations get released. And tell me in the comments, do you think this is just an unusual comet? Or does the pattern of evidence suggest we should be prepared for something more profound? I want to hear from you, especially those of you who've lived long enough to recognise when official stories don't quite add up. Your insights, your skepticism, your willingness to question comfortable narratives, that's what turns passive audiences into active communities capable of demanding answers. The countdown started weeks ago. We're now in the final approach to November 27th when the veil lifts and we get our first clear look at what emerged from behind that sun. Whatever we see, whatever the data reveals, remember this moment. Remember that once upon a time in late October 2025, an interstellar visitor prompted quiet activation of planetary defense, triggered scientific debate about whether comets can produce gamma rays, inspired predictions of electromagnetic interactions, and made authorities nervous enough to carefully control information in ways that suggest they know more than they're saying. In 60 days, we'll have answers, maybe comfortable ones, maybe not. Watch with me, question with me, and let's see together whether the universe is about to teach us something that changes everything we thought we knew about what's possible, what's natural, and whether we're truly alone in this vast dark forest of stars. If this investigation resonated with you, if you value this kind of deep analysis that questions official narratives and follows evidence wherever it leads, hit that like button to help others find this content. Share it with someone who needs to know what's happening. Subscribe and ring that notification bell, because when those November observations start coming in, you're going to want to be among the first to see what they reveal. Thank you for watching, thank you for questioning, and I'll see you in the next one when we dive deeper into whatever mysteries 3i Atlas decides to show us.